In the strange and mind-bending world of quantum physics, one particle stands out, a particle so mysterious, so rare, that it could change everything we know about encryption and quantum computing. Meet the Majorana Fermion, a particle that is its own antiparticle. First predicted in 1937 by the brilliant Italian physicist Ettore Majorana, this particle has eluded scientists for decades. While most particles have opposites, matter and antimatter, the Majorana Fermion is unique. It is both. It cancels and completes itself. Why does that matter? Because this unique symmetry gives Majorana Fermions incredibly powerful properties that could transform how we store and protect information. Let's start with a simple idea: encryption. In today's world, we rely on complex algorithms to secure our data. But these algorithms are vulnerable to one thing: quantum computers. As quantum computing advances, current encryption methods may soon become obsolete. Enter Majorana-based quantum encryption. Thanks to their topological nature, Majorana Fermions could be used to build qubits, the building blocks of quantum computers, that are stable and immune to errors. These so-called topological qubits are nearly impossible to tamper with. Why? Because Majorana qubits store information non-locally. Instead of storing data in a single location, it's spread across space in a way that makes hacking or observing it practically impossible. It's like having a password hidden in two separate vaults, where opening one destroys the other. This form of encryption could lead to what many call unbreakable encryption, a future where sensitive communication, from financial transactions to national security, is truly secure. But we're just scratching the surface. Majorana Fermions are also being explored as the foundation for fault-tolerant quantum computers. Current quantum systems struggle with errors and instability. Majorana qubits, by contrast, could bring quantum computing to new heights, solving problems in medicine, climate modeling, AI, and more. So where do we find these particles? Scientists are creating them in special lab conditions, using exotic materials like topological superconductors and nanowires cooled to near absolute zero. In 2018, researchers observed signs of Majorana Fermions in superconducting nanowire experiments, and the race has been on ever since. Their detection is challenging, their behavior is bizarre, and their potential is enormous. We're witnessing the dawn of a new era where particles once thought to be purely theoretical are now paving the way for a future of quantum security, supercomputers, and technologies we haven't yet imagined. So what's next? Scientists continue to explore, experiment, and decode the quantum rules that govern these strange particles. As our understanding grows, so too does the potential for revolutionary breakthroughs. If you're fascinated by quantum physics, encryption, and the future of technology, this is a story you'll want to follow closely. Like this video, subscribe to the channel, and stay tuned as we uncover the mysteries of the quantum world, one particle at a time. The age of the Majorana Fermion has just begun.